Hello my dear students, welcome to one more amazing session from Sri Chaitanya Academy Infinity Learn NEET YouTube channel. This is Suresh, Faculty of Chemistry. How are you all doing? In this Nirmaan 1.0 sessions, we are preparing for NEET 2027. How did you do? NEET 2026. In this NEET 2027 series, we are in the concept of molecular orbital theory. This particular molecular orbital theory, this is very important for those who are studying in grade 11 and grade 12 and preparing for droppers for NEET 2027. This molecular orbital theory is a theory which helps to predict the properties of the molecule, and it is connected to the quantum mechanical model of the atom. And when it comes to molecular orbital theory, everybody knows this is some molecular orbital configuration and bond order and magnetic properties. But NTA is observing the question patterns not directly based on bond order. Now the questions are being framed in such a way that theory oriented questions. So no doubt we will be discussing more about molecular orbital theory along with the theory oriented things. So let's see what is a molecular orbital theory over here. So those students who are online, please like the session, share with your friends and subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel. So let's talk about molecular orbital theory point to point. This is a fabulous approach developed by Millikan, and it decides the characteristics of the all bond parameters. And also this molecular orbital theory considers the entire molecule as an entity. You have atoms, you have electrons in the atom, and the atoms combine, so there is no more atomic orbitals. So the atoms जो orbitals है combine करके नया तरीका orbitals बन जाएगा, molecular orbital बोलते हैं वाला. And we will discuss about how the electrons are arranged in the molecular orbital configurations and everything. And also, so this approach recognizes the each electron belongs to the molecule as a whole, not as a single entity. So let's go in the details about this. So it is discussing about the overlapping of the atomic orbitals. When atom and atom combine, atom combine, you are going to get a molecule. So what is there in the atom? Atom contain atomic orbitals. Atom contain atomic orbitals combine to give rise molecular orbital. What is the scenario of the molecular orbital? आपको पता होना चाहिए उसमें. So like that's what I wanted to say. So only difference in the atomic orbitals. So atomic orbitals means the electron present in the atom is revolving in one nucleus, while this is a nucleus and this is an electron. Now this become a molecule, and this molecule the electrons are revolving like this. So the electrons present in the molecules revolve in the influence of the both the bonded atoms. That is, we can say atomic orbitals are monocentric while molecular orbitals are going to be polycentric. So here the term centric indicates it's a nucleus of the system, right? That's what I want to say. So the region which the probability finding of electron is maximum is called orbital. Hi Geeta Madri, how are you? One thumbs up. Okay. Now it may be noted that the molecular orbitals are not confined to an individual atom. The molecular orbital is confined to the total molecular orbital. Okay. So electrons, after formation of the molecule, there is no more individual entity. It is a common property of the total molecule. That's what I want to say. Yeah. So the molecular orbital possesses different energy levels, just like atomic orbital 1s, 2s, 2p, 3s, like that. Molecular orbitals also have the same scenario. So the arrangement we will see. We know these statements. After this class I want to take the entire thing in PDF format and I want to put in the Telegram channel. Please join in the Telegram channel ताकि आपको जो सेशन का नोट्स है PDF फॉर्म में ऑटोमेटिकली आपको मिलेगा. ठीक है मैडम. एंड हर स्टेटमेंट आपको दे रहा हूँ, it is going to be one of the statement in the multiple choice questions in the NEET examination. Are you getting or not clear? Right. Now I want to say the shape of molecular orbitals decided by the actual shape of the atomic orbitals. So simply in the NEET examination बच्चों आपको पूछा जाएगा, so NEET में which of the following statement is correct, which of the following statement is correlate with according to molecular orbital theory. Sir, Geeta completed atomic structure, questions practice today, entire chapter, and Geeta is right now doing periodic classification. अभी तो हम chemical bonding कर रहे हैं, so आगे chapter में आपको बढ़ रहा है. Okay, so level 1, 2, 3 and the previous year questions, that's fantastic. That's fantastic and all the best. अगर कुछ डाउट है ना तो सेशन के बीच में आप चार्टिंग में आपका पूछा जाएगा. ओके, प्लीज आस्क एनी क्वेश्चंस. नाउ मॉलिक्यूलर ऑर्बिटल्स अरेंज्ड इन द इंक्रीजिंग ऑर्डर ऑफ द एनर्जीज, जैसे आपका ऑफ-बाउ रूल का हिसाब से ये मॉलिक्यूलर ऑर्बिटल कॉन्फ़िगरेशन भी देना पड़ता. ओके, व्हाट इज ऑफ-बाउ रूल? समबडी इन द चैट बॉक्स प्लीज टेल मी व्हाट इज ऑफ-बाउ रूल. बच्चों, सो जितना एटॉमिक ऑर्बिटल्स कंबाइन कर रहे उतना मॉलिक्यूलर ऑर्बिटल्स फॉर्म होना चाहिए. दिस इज व्हाट इज कॉल्ड कंजर्वेशन ऑफ नंबर ऑफ ऑर्बिटल्स. द टर्मिनोलॉजी इज वेरी इंपॉर्टेंट फॉर नीट एग्जामिनेशन. And also you see, like atomic orbitals, the filling of the electrons in the molecular orbital should follow the same scenario as Aufbau rule and Pauli's rule and everything. What is Aufbau rule? I was asking Geeta, you tell me what is Aufbau rule? Electrons are filled in the increasing order of the energy of the orbitals. Okay, let's say conditions for atomic orbitals to combine atomic orbitals to form the molecular orbitals, that is given by the LCAO. What is LCAO? Linear combination of atomic orbitals. You see here, so the combining orbitals should be in the comparable energy, nearly the same energy, and the combining orbital must overlap to the greater extent ताकि stable bond form होना चाहिए. And also this is what is called a linear combination of atomic orbitals. So I mean to say, when electron means it is an orbital. Orbital is combining to form molecular orbitals, right? So electron quantum mechanics का हिसाब से electron is a wave, right? Like this. So when the wave is combining, this combination of wave has two methodologies. When wave and wave combines to give a bigger wave, and wave and wave combines to give a smaller wave. So what is this bigger wave? When the constructive interface में combine करने तो it is going to form molecular or bonding molecular orbital with a low energy, that is called constructive interface bigger wave. When the wave is joining, it is going to combine with a destructive interface, that is going to have higher energy, will have so anti-bonding molecular orbital. Atomic orbitals are filling electrons, the lowest energy level of Aufbau principle. Congratulations, that is what you wanted to say here. So diagram I just want to say, when the wave is combining, this is what is called as a psi A and this is going to be psi B is combining. It can combine with constructive interface, that is what is called as psi A and psi B with a low energy. It gives rise bonding molecular orbital. When it is combined with a destructive interface, that is said to be psi A minus psi B, it is going to give rise anti-bonding molecular orbital. When it form anti-bonding molecular orbital, there is going to form a nodal plane between the orbitals, where here nodal planes are going to be less. Understand? That's very, very, very important. So in the NEET examination, this wave mechanics based high level questions can be asked. Okay, I want to show you here various ways. So when this psi A and psi B is added, it is going to give rise bonding molecular orbital and anti-bonding molecular orbital. This is called bonding molecular orbital, anti-bonding molecular orbital. So if you see this anti-bonding molecular orbital, electron is going away from the nucleus. When bonding molecular orbital, electron is coming in between the nucleus. That is what? When atomic orbital combine, it gives the lower set of orbital is called as a bonding molecular orbital. When atomic orbital gives two set of orbitals, that is one is with low energy is called as a bonding molecular orbital, another one is with high energy is called anti-bonding molecular orbital. So this is the energy scale. So while the electrons are being fast filled in the bonding molecular orbital, then anti-bonding molecular orbital. So one question, what is how to count bonding and anti-bonding, one like 1s and 1 star, that, and the formula will be bonding minus anti-bonding. Questions, how we bonding and anti. So if two orbitals are combined, two molecular orbitals are formed. One is bonding molecular orbital, another one is anti-bonding molecular orbital. P orbitals 3 plus 3. So 3 supposed to be bonding and 3 supposed to be anti-bonding. अब जितना atomic orbitals form होना उसमें आधा bonding molecular orbital है और बाकी जो आधा है anti-bonding molecular orbital होगा. समझ में आ रही क्या गीता माधुरी? Right, you are on. Hope you are understanding the concepts. Right? So this kind of some diagrams can be given. आपको जैसे biology में मिलेगा, chemistry में NTA ऐसे questions, diagram based questions पूछने का संभावना भी है. Understand? Clear? If you have any doubts, please let me know, बच्चों. So could you give an example with oxygen? Of course, why don't I give? I will give. You are demanding or requesting, you tell me. If you request, I will tell. If you demand, I will give you more. Okay? As a student, you have every chance of giving a question. So, bachcho, in this YouTube channel, we are not promoting anything. Your humble request. Okay, because of this association between you and me, you always can give us. Feel like it's a one-to-one session. Okay, right. Thank you very much. Those who are online, please like the session, share with your friends, and subscribe to Sri Chaitanya Academy Infinity Land NEET YouTube channel. And in this YouTube channel, we are not selling anything. We are not promoting anything. We are giving a genuine subject for Nirmaan 2.0. NEET preparation 2027. Thank you. Thank you very much, Geeta. So those who are online, please like it. And as Geeta is starting with me, you can also take an opportunity, you can talk with us. Come on, let us say in the molecular orbital, formation of a bonding and anti-bonding molecular orbitals by LCAO method. You can see when s orbital, okay, s orbital with the same energy are combined, Geeta, you can see in that 1s orbital, you are going to get sigma 1s and you are going to get sigma star 1s orbitals. So मान के चलो यहाँ पर एनर्जी का जो स्केल है. Okay, so simple one thing, two atomic orbitals combines gives rise one set of low energy orbitals, another set of high energy orbitals. Low energy orbitals is called bonding molecular orbital and high energy orbitals is called as anti-bonding molecular orbitals. So bonding molecular orbital has less energy, more stability, and anti-bonding molecular orbital high energy, less stability. Is a universal fact. Energy and stability are inversely proportional. समझ में आ रहा है क्या बच्चों? Asking this, please clarify the oxygen atom. Oxygen atom थोड़ा सा सब्र करो. I will give you whatever you ask. आगे स्लाइड्स में है ऑक्सीजन का जो इलेक्ट्रॉन कॉन्फ़िगरेशन है. सो आगे बढ़ते हैं. अगर कुछ डाउट है ना तो पूछना जल्दी. एंड यू कैन सी दिस इज द वे व्हेन A orbital has an electron here, मान के चलो ये 1s ऑर्बिटल है एंड 1s ऑर्बिटल है, इसका wave function psi a and psi b, psi a plus b gives rise sigma, you can say this is a sigma 1s orbital, psi a minus b, this is anti-bonding molecular orbital sigma star 1s2. Are you getting or not? Clear? Any doubt? Bacho? That's good, fantastic. So like that you can see here. So the bonding orbital is designed simply as a sigma orbital. Anti-bonding orbitals are designated as sigma star. जिस orbital में star होगा ये anti-bonding orbital होगा. Okay, and you have such as a sigma axis. The sigma bond is the bond formed along the bond axis, and step please, yes, and pi is going to be a lateral overlapping wala hai. When you see 2p orbital and 2p orbital is going to get, this is the sigma 2p and this is what is called nucleus, and the nucleus, this is called sigma star 2p. Hi King, you are new, welcome to the class. King is always king, be like a king in the examination. Okay, and you see here, since the energy of this, you see lateral orbitals, you see when p orbital and p orbital is combining, it is going to give us pi 2px, while pi star 2px is going to distributed like this. You have pi 2px has a nodal plane and pi star 2px is going to have two nodal planes. So that plane, nodal plane का जो direction होता है ना, that has to be considered into the considered. So मान के चलो g axis का है, so this is going to be x axis. Okay, and you are going to see the nodal plane along the g axis. There a critical level questions can be asked in the JEE NEET examination. That's very important. Okay, clear? King is always a king in registering in MBBS counseling. So I bless you all, those who are preparing for NEET examination. I wish you go into your dream medical colleges. For that हमारा तरफ से मेहनत कर रहा हूँ, आपका थोड़ा मदद देना चाहिए. So stay with us and please like the session, share with your friends and subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel. Come on, आगे बढ़ते हैं यार. So two general criteria, so which determine the energy of the molecular orbital. उसमें initial energy of the atomic orbital. दूसरा है extent of overlapping, and it is obvious molecular orbital with low energy has a low energy as bonding molecular orbital. High energy are called anti-bonding molecular orbital. Sigma overlaps first, then pi overlaps next, right? That's good. Moving ahead here. So the relative energies of molecular orbital experimentally determined, that is up to nitrogen. Geeta, this is the sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px, pi 2py degenerate, then sigma 2pz, and then pi star 2px, pi star 2py degenerate, and sigma star 2pz. From oxygen onwards, you see, this is the molecular orbital energy diagram for oxygen and fluorine and neon. You are going to see sigma bond is formed first, then pi bond is formed next. So you will be having variation up to here. So the energy scale, this is your energy scale. Geeta, you got any doubt? You are asking about this only? Yes, this is only. Okay, always there will be my blessings, there will be with you, for you. And when the electrons are filled, first filled here, then filled here, then filled here, and then filled here, degenerate orbitals, then it is filled here. Okay, so this is the sequence you have to follow it, right? And at the end, I just want to give you the tricks as well. Now talking about So this is a exceptional for this is the one nitrogen, up to nitrogen this is the one. Okay, only for the oxygen pz comes here and pi orbitals goes there, and from oxygen onwards you have to follow that order. So Geeta, you are asking this only. Okay, now the main difference here for these molecular orbitals that I want to show you, yes, this is for beryllium, boron, carbon, nitrogen, and I said here only the difference is coming. Got it? So with the oxygen atom clarity purpose, definitely I will do it. Okay. So you need not have to draw these diagrams, but you need to know the pattern of the electron filling in this case, right? Now let's do some questions. Okay, these are all, yeah. Whenever electrons are filled in the molecular orbitals, you have to follow Aufbau rule. The molecular orbitals of low energy filled first, then higher energy filled next. Then Pauli's exclusion principle. No two electrons in an atom can have a same set of 4 quantum numbers, that is called as a Pauli's exclusion principle. And Hund's rule. Pairing of degenerate orbitals do not takes place unless these degenerate orbitals are filled with at least one electron with a parallel spin. So this is what is called as a Hund's rule. So I was asking, so if you write the electron configuration, could be atomic orbitals, could be molecular orbitals, these rules has to be followed. Understand? So talking about bond order, Muskan, you already done all the PYQs in hydrocarbons, congratulations, then why don't you ask doubts? You can ask doubts now. So bond order, it is defined as the number of bonds between two atoms. It is calculated by taking the super awesome formula. It is number of electrons in the bonding molecular orbital minus number of electrons in anti-bonding molecular orbitals by 2. Yes. So Muskan Verma, when I completed the PYQ, I completed alkanes and alkenes and arenes, you did PYQs. So do you feel the lecture given by me in the YouTube channel is helpful to you while solving the PYQs? Okay, just give me a thumbs up. Okay, moving ahead, I just want to say this bond order tells us the stability of the molecule, and you can see here it can be 0, 1, 2, 3 or can be fractional. Okay, now you can see if number of anti-bonding molecular orbitals, number of bonded electrons is greater than anti-bonded electrons, the molecule is going to be stable. If anti-bonding molecular orbitals equal or greater, that is going to be unstable. If bond order is 0, so such molecule never exists. Such molecule never exists. While bond order is equal to 1.0, single bond exists. Single bond exists. If bond order is equal to 2.0, double bond exists. And bond order is going to be 3.0, it is going to be triple bond exist. Fine. You asking, Geeta has a big curious question for a long time, please clarify. Sir, the students are sitting in front of you, or for live session you are teaching for Geeta, King and Mukesh. That's not the way. Okay, we are it is helpful, thank you very much. And you see here the classes that I am taking hundreds of students are watching in this class, right? So in this Sri Chaitanya Academy Infinity Learn NEET YouTube channel, 3.4 million users are there, right? And if you subscribe, you are going to be 1 point you are adding to the bond order, right? Come on, next. So there is a due fact that anti-bonding effect is somewhat stronger than the bonding effect. That's the reason why you can say whenever bonding electrons are increased, stability increases, that anti-bonding electrons are increased, stability decreased. Understand? Right, moving ahead, stability. Bond order half into NB minus NB. So stability of the molecule is directly proportional to the bond order, and dissociation energy and bond strength is directly proportional to the bond order. Okay, and also say bond length is inversely proportional to the bond order. So these are all the noteworthy point you need to know. And also various important point, magnetic moment. So you see here, and there is a compound is placed here, okay, compound. So we are going to see exactly equal weight. If you put a magnet over here, what will happen? It is going to pull in this way. If the compound has a magnetic properties, therefore it is going to move like this. So there will be a scale here, how much it is attracted. So this is what is, we can say, magnetic moment. If a compound in its molecular electronic configuration, if you have unpaired electron, it will be attracted. So such compounds are said to be magnetic compounds, and such compounds are said to be paramagnetic compounds. Can be explained on the basis of the magnetic moment. Nu is equal to root over n into n plus 2. N is going to be number of unpaired electron. If magnetic moment mu is equal to 0 Bohr magneton, it is said to be diamagnetic. Diamagnetic means it has no magnetic behavior. Classroom. Okay, in the classroom or in the live class or the offline, online, we teach and we make the class always lively. Those students who are online, please like the session, and it is going to be, if magnetic moment is greater than 0, is going to be supposed to be paramagnetic. So it is said to be paramagnetic. Okay, so you can say dipole magnetic moment is directly proportional to n, isn't it? Understand? Thank you, Geeta Madhuri, thank you. And I just want to give you a super trick before we just go through. Yes, here it is. Yeah. Super trick that you can use directly in the NEET examination. Believe me, you can use this. Everybody take a pen and paper. And you can just observe what is going to happen here. So it is going to be a trick. Write 9 to 20 and take the nitrogen 14. Its bond order is going to be 3.0. So from 3.0, decrease 0.5, 0.5, 0.5, 0.5, 0.5, decrease 0.5, 0.5, 0.5, 0.5, and 0.5 and 0.5. Okay, so if you take the number of electrons into the consideration, okay, let's see here, nitric oxide, that's what we discussed. So carbon monoxide. Carbon monoxide has, carbon has 6 electrons, oxygen has 8 electrons. Is going to be how many? 14 electrons can be written. Kk mean to say sigma 1s, sigma star 1s, sigma 2s2, sigma star 2s2, pi 2 px. It goes like this, but you can directly do by using this 14 electrons. Yes, 14 electrons you can do it. And also if we want to talk about nitric oxide, okay, nitrogen has 7 electrons, oxygen has 8 electrons. Okay, now it is going to get 15 electrons. 15 electrons means I want to say bond order is 2.5. Clear? In the previous one it is going to be 14 electrons. Any doubt? You want to make it oxygen. Oxygen, it is going to be 8 plus 8 is equal to 16 electrons. 16 electrons means it is going to be 2.0. Understand? Simple, no? This trick is wonderful. You can handle it. It can help you in the NEET examination aspirants. Right? As Geeta is saying, everybody, any species you can say. O2 plus, O2 2 plus, O2 minus, O2 2 minus. You can simply say how many electrons it could be. It has 16 electrons. It has 15 electrons. It has 14 electrons. It has 17 electrons. It has 18 electrons. Yes. Now you can write the bond order values here. It is going to be 2.0, 2.5, 3.0. Again O2 minus 17 electrons is 1.5. It is 1.5, 1.0. Could you tell me the order of stability here? Stability, that is O2 2 plus is greater than, O2 plus is greater than O2, O2 minus is greater than O2 2 minus. It is there. Geeta took the screenshot of this table. Everybody can directly use this table, and without understanding even molecular orbital theory, you can do this. Thank you so much. Thank you so much. Now, as this time is so valuable and time is also limited, we will meet with more stuff in the next upcoming sessions. As the time is exhausted, we shall meet with more stuff in the next class. Thank you very much. Those who are online, please like the session and share with your friends, and subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel, and we'll meet with more stuff and upcoming sessions. If you want to get the update, please press the bell button so ताकि आपको notification भी मिल जाएगा. Understand? Okay, then thank you very much. We'll see you soon, and if you require any specific topic to be explained in the live class, please mention the comment box so that I will take into the consideration. Thank you very much. Bye-bye. God bless you. NEET UG exam. Do or die. No die, only we do. Okay, thank you very much. Bye-bye.